Hello and welcome to Saurav Sir's classes. Today we are discussing the ISI 2019 paper. In this question, we are told that you are given a 4 by 4 chessboard and asked to fill it with 5 3 by 1 pieces and 1 by 1 piece. So, over all such fillings, the number of squares that can be occupied by the 1 by 1 piece is what? So let us look at the chessboard first. The chessboard would be a 4 by 4 one, so it will be a square and there would be 16 squares. So 1, 2, 3 and 1, 2 and 3. So there are 16 squares and we can fill 5 3 by 1 squares in this way. So one of them would be like this, then the second one would be like this, third one would be like this, fourth one would be like this, and fifth one would be like this, and the remaining one would be a 1 by 1 square, which would be this one. So this is one of the ways by which we can do it. There are only 4 ways in which this can be done. So this is one way. The second way could be, again we draw this 4 by 4 square, 1, 2, 3 and 1, 2 and 3. So the second way could be, the 3 by 3 square comes here, 1, 2, 3, 4 and 5. So the empty one, which is the 1 by 1 square, so this comes here. So notice last time we had this one, now we have this one, so it can be repeated with all the 4 corner squares, and that's it. So the number of squares that would be occupied by the 1 by 1 piece would be 4. So option A, 4, is the correct answer. We come to the next question. In this question, we are told that a brand called Jogger's Pride produces pairs of shoes in 3 different units that are named as U1, U2 and U3. These units produce 10%, 30% and 60% of the total output of the brand, with the chance that a pair of shoes being defective is 20%, 40% and 10% respectively. If a randomly selected pair of shoes from the combined output is found to be defective, then what is the chance that the pair was manufactured in the unit U3? So let us see what is actually given. So we have 3 units, U1, U2 and U3, and they manufacture either defective or non-defective, and let the total number of units be 100 manufactured by all 3. So therefore we are told that 10% is manufactured by unit 1, so this would be 10, 30% is by unit 2, so this would be 30 units, and 60% is by unit 3, so this would be 60 units. And the percentage of defective is 20% for unit 1, so out of 10, 2 would be defective, 8 would be non-defective. For unit 2 it is 40%, so out of 30, 12 would be defective and 18 would be non-defective. And for unit 3 it is 10%, so out of 66 would be defective and 54 would be non-defective. And if we add up the defective row, it comes to 20 and non-defective comes out to be 80. So this is the split of the shoes across all the 3 units. And if we select a pair of shoe and we find that it is defective, then it comes in this row. So that means we are picking one of the 20 defective shoes. And what is the probability that it has been manufactured in unit 3? So it would be 6 by 20 into 100. 6 by 20 into 100. So which is 30. So 30% is the probability that the defective shoe was manufactured in unit 3. So option A is the correct choice. We move to the next question. This one says that consider a paper in the shape of an equilateral triangle ABC, and the circumcenter of that triangle is O, and perimeter is 9 units. And if we fold the paper in such a way that each of the vertices A, B and C gets identified with O, then the area of the resulting shape is what? So let us draw the diagram. So we have the equilateral triangle like this. So this is our equilateral triangle, and we have to fold the vertices A, B and C in such a way that it coincides with the circumcenter O. So that means the folding has to happen like this. So the folding will happen like this. So this part of A will get folded inside. Similarly, we will have folding here, and this part of B will get folded inside, and similarly we'll have a folding here where this part of C will get folded inside. So the resulting shape would be this, this, 3, 4, 5 and 6. So it will be a regular hexagon, and the sides of this hexagon would be, so the sides of A, B and C are 3 units each because the perimeter is 9. Perimeter of ABC is 9. Therefore each side of the equilateral triangle is 3. So we will have this divided into 3 parts. So 1, 1, 1, 1, 1, 1, 1, 1, 1 would be the dimension of each side, and this part of the original triangle will get folded inside. So these 3 shaded triangles are all equilateral triangles which will have the area of root 3 by 4 into 1 square, and the area of the original triangle ABC area is root 3 by 4 into 3 square, that is equal to 9 root 3 by 4, and from that we have to subtract 3 small areas, 3 small triangles which are shaded, and that area would be 3 into root 3 by 4 into 1 square, which is 3 root 3 by 4. So therefore the area of the resulting hexagon would be equal to 9 root 3 by 4 minus 3 root 3 by 4, which is equal to 6 root 3 by 4 or 3 root 3 by 2. And we can see option C is given as 3 root 3 by 2, which is the correct choice. We move to the next question. This one says let P be a regular 12-sided polygon. 12-sided polygon. The number of right angle triangles formed by the vertices of P is how many? So let us see how this polygon looks like. So 12 sides means 1, this is 1 side, this is 2 side, this is 3 side, this is 4 side, this is 5 side, 1, 2, 3, 4, 5, and this is my 6th side. So likewise on the other hand, or on the other side, we will have 6 sides. So 1, 2, 3, 4, 5 and 6. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13 points. So there was a little mistake. We take this off. So now we have 12 sides. So now we have to see for one vertex how many right angle triangles are possible. So this vertex will make what angle with each of the vertices? That is the question. Now in a 12-sided polygon, interior angle, each interior angle will be equal to 180 minus 360 by 12. That is equal to 150 degree. So each interior angle will be 150 degree. So let us name this point A, which would be our basis. So all we are trying to do is to find out how many rectangles are possible through one point or one vertex, and then we'll multiply that number with 12. So let's start with A. Now if I name this point B, so A makes 0 degree with point B. This is 0 degree. Now come to point C. Now with point C, we know that the angle B is 150, and if I join A and C, the two sides of this triangle are equal. They're the sides of the polygon. So therefore the other two angles will be equal, which means 150, 180 minus 150, which is 30 divided by 2, 15. So this would be 15. This angle made by A with C will be 15. And so on the other side, this angle will be 150 minus 15, which is 135. So this would be 15 and on one side, 135 on the other side. If we come to point D, now this is going to be a quadrilateral. So angle C and angle B each would be 150 into 2. So that is 300. The total sum of the angles of the quadrilateral is 360. So this angle which A makes with D, the angle made by A with the point D, which is this angle, is 60 by 2, which is 30 degree. So this would be 30 on one side and 150 minus 30, which is 120 on the other side. Similarly, we can show that with point E, it will make 45 on one side, on the other side it will be 105. With point F, it would be 60 on one side, 90 on the other side. And with the point G, it would be 75 on each side. So this is how any point in that polygon will make respective angles with each of the other vertices. So now we have to see how this works. So if we go on the other side, we will have the same logic. So angle is 0 here, 15 on one side, 135 on the other side, 30 on one side, 120 on the other side, 45 on one side, 105 on the other side, 60 on one side, 90 on the other side. So this is how each of the vertices will make their angle with the point A. So we have to find combinations which will give us 90. So 150 minus 60 is 90. So for example, if I go to the point B, the point B has 0 degree. So it will make an angle of 90 degree with this one. So this angle will become 90 because this angle will be 60. So that is the logic. So with B, we have this one. So that will give us 190 degree angle. With C, which is 15, we will have 45 So 16 plus 40, 15 plus 45 is 60. So the angle in between these two, would be 90. So therefore 15 and 45 would be one pair, 30 and 30 would be another pair, 45 and 15 would be the fourth pair, and again 60 and 0 would be the last pair. So we can see 1, 2, 3, 4, 5 rectangles are possible. 5 rectangles are possible on each vertex. And there are 12 vertices. So 12 into 5, total of 60 rectangles are possible. So we can see option A as 60, which is the correct choice.